三支线在我们靠近我是农业工程研究中心的。那之前有请 Mark 到现场帮我们指教一下。那我们中心是买了一台 S5，很久以前就买了一台 S5，用很优惠的价钱啊。然后现在平常是在那个石门水库上的集水区都是我们在做测谎的，那个流速也是都5啊6啊都很大。但是没有用它这一套，因为太贵了，我们舍不得用。它那个上游会有很多漂流木，比大陆便宜。然后它那个漂流木会撞击它，所以我们就没有在用。我们在上游还是用传统丢浮标。那这一台只用在这个桃园大郡这个8米宽的河道，然后它流速大概1.5而已。那个就是在这个平稳的测出来，因为桃园大郡跟北区水资源局常常会有一些用水的纠纷，比如说他说他放了13，可是在下面都看不到，他说我这边就看不到13，所以他们就找一个第三公证单位，就找到我这边，用这一台他们才承认。以前用那个传统检测都不承认了，他就要用这一台了。用这一台以后，北水局的跟石门水利会、桃园水利会跟我们就现场就马上检测，然后就给他们看数据。那他们就认了，该放多少就补给他们，这样以这一台为主。让大概介绍一下，谢谢。
Okay, thank you. Yeah, so besides, so this is an irrigation canal that we were at. So in addition to the moving boat profiler, you can also see a fixed sensor here. This device here, this is a side-looking system. So if you want continuous data, you would use this side-looking system, and that's mounted on the wall of this irrigation channel, and then it shoots its beams into the channel. So it's continuously measuring a time series of the velocity, and also there's a vertical beam to measure water level. So with velocity and vertical level, or water level, we can compute the discharge. But they work together, and that's a whole other topic of how to use the M9 S5 to calibrate this side-looking Doppler to give you discharge, because the measured velocity is correlated to the mean velocity of the channel. But that's a whole other topic. That's another half-a-day topic. But I just wanted to show this to you since Professor's here.
那我这里再补充一下刚刚Mark那一张照片就是桃园大郡，它有很多支线，它很多支线，那现在它还有给水给那个大南水厂，水利会都会加强这样管理以后，会有多的水会提供给人家使用。然后但是它跟大南水厂又有纠纷，大南水厂就觉得我没拿那么多，你为什么说我拿那么多？所以又找到我，所以我们就在那边的时候，就是会用这个，在那个支线取水之前，先用这个船拉一下。然后取水完以后，在它下游地方再拉一下，这样去扣说看它拿了多少水。所以这个照片是有另外在做更小流量的检测。不过效果不好因为它桃园大郡它的水位晃动很大，大概0.6 cms 以上的都不准，所以以下的都不准，它的误差就是0.6，所以超过0.6 cms 以上的才可以做。那另外一个北水局也是买那个塞鲁肯的买2台，北水局他跟苏老板买的嘛，然后北水局也是在怀疑他那个东西到底准不准，所以也是找到我是把那一台拔下来放到桃园大郡。刚哥有看到那个塞鲁肯的 SL500的那一台，也是用这个船去检查它量出来的流量准不准，都是用这一台。
So I just want to talk about this special case here, where you have a vertical wall, which is different than a sloped bank that you may have on a natural river. This is a sloped bank, this is a vertical wall. As mentioned, we have a vertical may have slant beams. Both of these can measure depth, water depth. The slant beams measure velocity as well, vertical beam only depth. But in his case here, in Taiwan, the boat we want to measure is, our purpose is to measure as much water as we can. So when we move this boat here, we want to get as close to the edge as we can to measure as much water as we can. But when the boat gets very close to the edge, this slant beam here hits the wall. Right? So this depth here, all these depths are different, right? So if we want an accurate depth, and we have these 4 beams. So we have one, this is the vertical beam depth. 1, 2, and then we have 4. And it averages all those together, right? So it averages the depth from the slant beams. So if you use the depth measurement here, it won't be as accurate as using the vertical beam depth. So in this case here, that's the advantage of a vertical beam, is when you're near a vertical wall, you can get very close, and in the software, you can select vertical beam for your area calculation. And so you get much better data by using the vertical beam. This is an example of when you use vertical beam depth, is when you're near open wall. In a big open river with slanted slopes, yeah, then you can use vertical beam depth, okay, or slant beam depth. But for this case here, the vertical beam is important to use in your discharge calculation. Another point about in Thailand is that they have this SL. So this is called a side looker device. This is our S5. But in Taiwan, they also have a side looking device here. And it's measuring a section of this channel. Okay? So this is what we measured. Okay? But in the discharge calculation, it's area times mean velocity. But here we're measuring a subsection. It's a subsection of the whole channel. What we want to have is mean velocity. So we use M9, go back and forth. And that device calculates V mean, the mean velocity. So we use them together. We use M9 and SL together to build a relationship So by using the subsection and the mean velocity at the same time, we establish this relationship. When we use linear regression, by knowing the slope of this line and the offset, we can get mean velocity. So that's why it meant that we calibrate SL with S5 for this case, or in a bigger channel with M9. So we use these together to make this rating. This is called called velocity indexing. Okay? So people who want a continuous measurement, they would use this SL device together with the M9. Okay, so earlier I mentioned about VTG. VTG is an alternative. So if you have tree coverage or high building, you have multipathing. VTG is a nice tool to have as your backup. Okay, and it's Doppler based. Down here I mentioned about the SBAS correctors. So in America we have WASP. Here in Asia it's called SBAS. And I believe this is either European measurement for geostationary for the correctors. By the way, this is our new Hydroboard 2. Okay, so it's one piece. Triman is very good. This one here has what's called an anti-diving system. So you'll see a bungee cord here and here. This might be useful for Taiwan. Anti-diving This whole thing is made of a closed cell foam. If the nose goes down in the water, if it starts to dive, the bungee cord will pull it back, and so it snaps back up in the water. That's the purpose of this bungee cord. So if it does go down underwater, the bungee will snap it back and it'll come up to the surface. The old hydroboard was a hard plastic, and when it went down, it really went down, like a sail. It was dangerous. So this hydroboard tube has this anti-diving system. So I think it might be useful for here in Taiwan for fast flows. And I believe this is rated to 5 meters per second. We've done tests. Okay, this is the RTK system that I mentioned earlier. Again, this is the options we have: hydroboard 2, and then the trimaran. There's actually a high-speed version of the trimaran with a longer center hull. All right. In this presentation, I want to talk about site selection. Okay? So with Doppler devices, you can't use it in every location. There are limitations. Just now at the break, we talked about eddies that are coming downstream of a bridge. Okay? Or maybe there's a rock in the river that's generating a lot of turbulence. Or the river has a turn. If you try to measure it in the elbow of a river, there's a lot of circulation. Right? So there are some fundamental requirements when using Doppler that you should always look at and before you install and before you operate to make sure to get good data. So there's definitely hydraulic conditions, environmental conditions. You want areas that represent the total flow. So I'll go through some of this here. The fundamental thing is what's called homogeneous flow. I'll just grab that here. I'll use the case of, we just use the SL for now. But if we have a beam here, and a beam here, if there's a lot of turbulence in the river, maybe one beam is here, and then it's doing this, and it's here. We actually average this data. Okay. And when you combine these together, you're not going to get the real value unless you a much longer average in time. So we look for rivers where the flow is more homogeneous across, with less turbulence. So bridge sections, these can cause flow disturbances. Bridge piers. If you have a culvert, and the water is coming out of the culvert, you'll have diverging water. Right? So you'll have vectors in different directions. So you need to get away from culverts and away from bridge sections. So if you have a bridge and these pilings, you get some of this eddies that form here. So you want to get further enough away from that to avoid this recircling area here. Because you'll have 4 beams. Maybe one here, one here, one here, one here. You can imagine to get homogeneous flow across all beams is difficult. You might have one vector that way, one this way, that way, this way. Right. So this area is very challenging. So you need to move away from the bridge or get a clean signal upstream. Or you can use stationary, but you have to hold it here for a long time, maybe 100 seconds to get a steady value. But for a moving boat, you want to get further downstream. This is more for pipes and for, we also have much smaller devices called the IQ, about that big, that you can put inside of pipes or open channel. And these are some of the cases here. We talked about the stream bed. We talked about factors, vegetation, okay? If you have a lot of plants at the bottom, okay, that's going to interfere with your beams. You're not going to be able to measure all the way to the bottom. Or if the beams are moving like this, and you try to bottom track, you're tracking the movements of the weeds, not the bottom. You can also have moving materials. We talked about moving bed, sliding and rolling of sand, rocks. So that's when you want to fall back to using differential GPS or RTK. Or stationary if you have a moving bed. So you want to look for locations. Sometimes you have to do site survey to find the most suitable place before you measure. If you're using the GPS, and if you're using for bottom tracking, you have to correct for any magnetic disturbances. One fundamental one is on the Earth. Okay, so we have the North Pole, we have a magnetic North Pole, and then we have the real North Pole, right, the true North. There are some differences. The compass that we use inside we have a compass, the wall pot, and it's a magnetic compass. Right? So if I take my mobile phone, it will affect the compass inside here. Okay? So you have to understand the ambient magnetic field, which is the declination, right? Which is the offset between magnetic north and true north. There's actually applications you can get on the internet for magnetic declination to get that angle. Or on the web. To get here in a tide zone, it might be -5 degrees. I don't know, but we can check later. -3. So -3. And so in our software, we can make that correction between true north and magnetic north. In addition, if you're near a bridge, this bridge may have a lot of metal, a lot of steel inside it. Right? So if you do the M9 right near the bridge, you might see the compass move because there's a lot of steel in that bridge. Or if you're using a boat, there's a motor, so you want to keep it away from the motor on the boat. So these are other factors that you need to consider. Flow distribution, reversing flow. So sometimes in rivers there's eddies that form on the edge of the rivers. So you're trying to get rivers that are as uniform as possible and there's steady flow. Sometimes you have no choice. Again, vegetation, sediments, salinity. We talked about that earlier. By using castaway, the CTD, to get the speed sound correction. Because you'll have different density layers, and that will affect the accuracy of the depth. Wildlife, yeah, maybe fish, I'm not sure. Okay. So some of the standard tests that we do, even before you make a measurement, even before you make a discharge measurement, you need to do a diagnostics check. We have to do something called a compass calibration, where we need to align the magnetic compass in the M9 with the GPS heading. can understand the ambient magnetic conditions. So we have a procedure in our software. It's called the compass calibration, where we pitch and we roll the sensor to observe the surrounding environment and to make some corrections. So we call that a compass calibration. And also it's a check about the magnetic field. Check the temperature, make sure the temperature sensor is working and ambient. We might do a bed test. So the USGS in America, before they do a discharge measurement, they have to do a moving bed test. That means they go out to the middle of the river and they hold position for 15 minutes and they look for any changes, any bed movement. So when you're looking at the software, if there's a moving bed, it looks like the boat is moving upstream. Okay? That means your bottom is moving. Beam check. Beam check is to make sure that transducers are working, nothing's cracked, you're getting full range. No obstructions, there's no rocks or trees in the water. So you need to run all of these checks. There's 5 of these checks that you should do before you measure. So these are some of the tools that you do. Site reconnaissance means maybe you go out the day before or a week before and you look at the site and you look around for the best place to measure. You make a plan. Because if it's raining and it's a typhoon and then you go, you don't have time to find a good location that's convenient to put a boat in the water or you have access to. So you really want to do this before it rains, before a flood, or so you have time to investigate. Check the section, make sure there's no big rocks or obstructions or vegetation. Take some photographs. If you're near a bridge, you can observe. If you see oils coming up on the surface, and maybe there's a lot of upwelling turbulence. So just from your eyes, you can look at the river and see where the flow is more stable. And you might want to go out with that now just to do some sections to check for the bottom. Okay, any questions on site selection? No? We'll go through some examples now. Do you guys drink coffee? You're very quiet. Are you sleeping or? Yeah, don't be afraid. You can ask questions. But my Chinese is not so good. But if you want to ask questions in Chinese, I can try to understand. Or David can help to translate.
If you want Mandarin or if you want English.
But I'll go through some examples here. So here's an example of a bridge pile right here. And you can see how it affects the flow. Okay. It reduces here. See, in this case here, you might want to go further downstream to minimize this effect. Interesting here. So we just talked about magnetic influences. So here's the tiling, right? There's a lot of, we call it rebar. So the iron pieces that are inside the concrete that add the structure to the tiling, those are full of iron. And you can see here how that's affecting the compass inside. So here's what can you do? Let out more tagline. Okay. If you're using, if there's no moving bed, then you can use bottom tracking. And bottom tracking actually doesn't use the compass, so you're okay. So if there's no moving bed, you switch to bottom tracking. But if there is a moving bed, you need to use the magnetic compass because it's aligned with the GPS. In that case, you have two choices. Let more cable out to get further away from the bridge, or you have to go to another location.
Question.
Yep.
How do you check the bed is moving back or not?
Okay. So check for moving bed. Check for moving bed. You go out into the river where there's fast water. And you may want to check in more than one location. But you find there's fast moving water, and you put the M9 there, and then on your computer, you're running the River Surveyor Live software. And you have your screen that shows the river, and there's the M9. If there's no moving bed, and you do this for 15 minutes, so the USGS is 15 minutes. Hold position, don't move, but keep it in one spot. If there's a moving bed, you'll start to see it to move upstream. Okay. Because the M9 is watching the bottom, and and it's tracking the bottom. Right? And if it sees if it's moving, it will think, oh, I'm moving. But in fact, it's not moving. So it's a stationary test. So moving bed test. Moving bed test using River Surveyor Live software, holding it in position for 15 minutes, and then watching the boat track. If it starts to move upstream, and it's not continuous. Moving beds are, it starts to move like that, and something like that. So it's non-linear moving beds. But if you start to see it going upstream, and you know it's not moving, then you have a moving bed. And if you have a moving bed, then you have to start thinking about other options. Then you need to use GPS or stationary.
So before the flow measure, you have to check your back condition, right?
Right. So just like before, the other slide, before any measurement, you need a diagnostic check, moving bed check, compass calibration.
Standard procedure.
So there's a standard SOP, standard operating procedure that you need to follow if you want to have high quality data.
So tomorrow, when we go to the field site,
You can do stationary for sure.
okay,
Yeah. So you can do this tomorrow.
okay.
And we'll go through all the steps that we should do
Mm-hmm.
for good practices. But yes, moving bed is very important. Okay. So here, this is an urban area, and you can see some buildings and bridge piers and things. You start to get effects, local effects, maybe magnetic effects near the edges here. So do people understand what the different colors are between red and blue? Anyone know? So one is bottom track, and the other one is GPS. So we plot two tracks. One is bottom track, the other one is GPS. Now, if you have RTK and VTG and GGA, you actually have 4 tracks on your screen. Right? And it's your job to figure out, okay, which one is correct. Do I have multipathing? Is there a moving bed? So again, you have more tools when you watch the river. Then you have to use your judgment, and you have to use our software to figure out which one is the most reliable, and what gives you which is correct.
So this part, legal, also more detailed except.
Yeah, we'll talk about this much more. Okay. And here's using the stationary test, well, the stationary method, where you can see near the edge. magnetic. So you can use X, Y, Z. So on our M9, we have a small arrow. There's an arrow on here. That designates the X direction. That's the X direction. And then Y, and then Z. Okay?
Facing downstream.
Right. Actually, it doesn't really matter. But for stationary, it's downstream. But for river surveyor, it could be in any direction. It doesn't matter. So on our system, so from here we have beams. So we call this the beam coordinate system. 1, 2, and then we have 2 other beams. And then on the M9, we also have Y. And Z. And then we may have so the data is collected as a beam coordinate system, and then there's a transformation from beam coordinates to X, Y, Z, because we know the angle of the beam's locations. So we generate X, Y, Z data. And this is no compass. And then with a compass, we use the Earth coordinates, east, north, and up. East, north, and up. Because we have a compass inside. Okay. But if you have magnetic effect or a bridge or something, you can switch back to X, Y, Z. Okay. And that may be what you want to do with stationary. In that case, you have to know what is your X. You have to point it upstream. You have to know the orientation at that point if you don't want to use the compass. There's a big magnetic effect. Okay. This case here, this is vegetation. This means plants. So in some parts of the world, in the winter time, maybe the section is very clear of plants. But in the summertime, you have more vegetation. Okay. This vegetation will affect your data, very much so. And you can see cases here where we lose data. We lose bottom tracking related to vegetation, grass in the water, or some sort of plants that affect the data. So that's another reason to go out and check a section first before you make a measurement. Look for places where there's less vegetation. Or if you're in a small channel, you can clear it. If there's a rock or plant, you can cut it or take it out. If you're in a channel, maybe he would go out and look for the best channel, or to remove something to have a nice channel. Right? USGS does this. Okay, so before they do a discharge measurement, they may clear the channel so it's nice and smooth, and then do their calculation. You can't do it, but in a big river, it's not possible. Okay, so these are areas where there's impact from vegetation. Okay. So first look at the raw data, and then check the ship track to see if there's any changes or deviations. That can also give you indications. So in this case here, this is the bottom track data here. So then you ask yourself, is that vegetation or is that a compass problem? Right? So if you just look at that data, you don't know. Is it vegetation causing that? Or is there a magnetic interference from a bridge piling or a boat? So you have to do some research. To figure this out, You switch between X, Y, Z, and E and U. So if you don't know, you can change the coordinate systems. There's no difference, right? So it must be vegetation, not compass. If it's compass problem, X, Y, Z is beautiful, and E and U is not so nice. Right? That's how you know this is not compass. So that's a good way to check. You go back and forth, and that eliminates the compass problem. Then, oh, it's vegetation. So there's different tools in how to check the data to know is it vegetation or magnetic. People understand this concept? David, Sue? Okay. So here's a case here. Very low water velocity. There's no moving bed. What do you guys think? There are probably weeds in this case. Okay. Here's some more interferences on compass bank on compass due to magnetic interference. This is quite a complex site. The data can be pretty different between GG reference and bottom tracking. Pretty substantial difference. But I guess the question is, how do you know which one's correct? Right? Is there multipathing? Is there moving bed? Well, first of all, there's no moving bed. Does anyone know why? So if you have moving bed, the discharge will always be biased low. Okay? If there's a moving bed, your discharge will never be higher than if you're using GPS. So that's the first thing. So if there's a moving bed, discharge will be less. In this case here, bottom tracking is higher than GPS. So it's not moving bed. Okay. Look at the directions. Why? Okay, here's an impact. Steel reinforcements in the bait causing deviation. So here you might want to use stationary using XYZ if you really need to measure here. This might be a challenging location because of the reversing flow, but if you did need to measure here, you could use XYZ and not use the compass. So see, these are some examples of river square measurements and what to look for to avoid vegetation influences, avoid magnetic interference, how to determine what's magnetic, what's vegetation. Talked about avoiding the excess of turbulence. Okay, any questions on these slides? Talk about software setup. So this is our standard GPS compass that we offer from SonTek. We have another compass that we offer here. Does anyone know what this is? It's a little bit different. This is round and that's a different shape. Anyone know what that is? That's a GPS. Does anyone know what that is? Any ideas what that is? two GPSs. So it's like that shape. And if you took the lid off, there's two GPSs inside at a distance. Okay, I'll put it like this. So as the boat's turning, it's doing this. And it's using the GPSs to get the heading, to correct for the heading. It's very nice. And we can integrate it with our system. Then you don't use the compass at all. Then you're just using this heading. Okay. We call that a GPS compass. And that's also an option that you're able to get integrated with the PC. That's really nice if you're on a boat where there's a lot of metal, or there's a bridge, and you want to have no interference. You want simple, simple, simple. You can use this GPS compass. Okay. So in software, it's very intuitive. You start at the top and then you work your way down, and then we have tabs that we fill out beforehand. So this is for connecting to the system. And how to open and receive data. This is the tabs at the top. This is for connecting the system. So again, we're using either a direct system, direct cable, or we're using a radio system to connect. We have auto connect, and we have a new feature for manual connecting. You can choose either manual or auto connect. It's very simple. My one comment I would like to make is to always use this USB connector. The data rate through here is much faster than if you use the standard serial. Okay? So always make sure you use the USB converter, because the port here, the USB port on my computer can handle higher data rates than the serial port on my computer. So always use the USB, because the throughput is much faster on my computer. Okay? So always use the USB for faster data rates and more reliability. Okay, we call these smart pages, because there's a logic to this. We start at the top and we fill in the data as we go down. And the same thing for when we start to collect. We have tabs across this way. So it's very user intuitive on what to do. And as we click through the top to bottom, it goes from red to green. If it's red, that means you need to do something, put something in. And then it changes color to green after you enter information. Okay, here in Taiwan, we're using metric system. We set the time. We can have it set to your PC time. And we do system checks. So we talked about dynastics. This is one of the checks you want to do, is to check the battery, check the compass, recorder, and the temperature. So these are just more procedures that you want to do before you measure. It's a systems check. Site information. You can imagine, as a hydrologist, you go out many times a year, 20, 30, 40, 50 times a year, many different sites, and you have a lot of data. So make sure you put in the site name, the location, who was there, the operator, other comments, maybe there was a wind that day. Heading source. So for the heading source, you can select magnetic compass for heading, or the GPS compass for heading. You want to put that in here. You tell the software which one to use. And actually in our software, we have a priority system. So it ranks it. So the first choice may be GPS compass. The second choice might be magnetic compass. So there's always a backup. If something fails on GPS compass, you have the magnetic compass. There's another one for tracking. Maybe you want to use GPS first and then fall back to bottom tracking. Maybe the satellites go away. Maybe you're using RTK and it's very cloudy or there's a storm coming through and the signals are weak. It might fall back to bottom tracking. In addition to the simple moving bed test we talked about, the 15 minutes, there's two other methods, actually one other method. And one is called the loop method. And the loop method means if you start here, and you cross the river, come back, you should come back to the same location. So it's a loop method. This is called the loop method. This is also a check for moving bed. The moving bed I mentioned earlier is for 1 point. It's very simple. But if you wanted to check the whole river and to figure out what sort of offset you can apply, you can use this method. It's called the loop method. We also provide that in our software. So you should come and go back to the same location. If you do this, if you do this, and you come back at a different location, that means there's a moving bed. The bottom is moving. Then you have to decide, do I do stationary? Then I have to use GPS. Then you make a decision what to do next. So there's a decision tree that you need to follow on what step to do. This is some new software for our calibration. So we recently released a new compass. And with this new compass, we actually have a magnetometer inside of it. So the new compass measures the ambient magnetic field. And we have a new way of doing the calibration, which we'll do tomorrow. So you'll learn about the new calibration. But the calibration involves turning